Hello and welcome back everybody. Today in geometry we are looking at what is known as a unit circle. So this is a continuation on the trig identities that we did a while back, and also the trig ratios. Basically kind of like, as with one of our foot going into the trig scenario then with the on topics. So anyhow, the idea is now that we know how trig functions work, like sine of theta or cosine of theta or tangent of theta, I want to know how to extend beyond that. Meaning, like, say, if we have a triangle that is not 90 degrees, not a right triangle, how do we apply sine, cosine, and tangent to all of that? So that's where the unit circle actually comes in. So that's the idea behind today's unit. So let's go ahead and first recap first as to like what happened in the last section. So in the last section, which is 17.5, we learned about something called the winding function. So the winding function is basically kind of like a way you look at an angle. So if you can kind of look at the picture underneath over here, you'll notice that we have a side over here, which we are going to call the initial side. So because we're creating an angle, that's why we need a side. So that's the starting point. And on the circle, we're going to basically go counterclockwise by a certain amount. And that angle is going to be according to the central angle over here. We'll go ahead and call theta. So that is going to now create an angle. And this right here will then be our terminal side. So that is going to be, the setup for an angle then. So the position that you're at right there, that is going to be how we define the angle of the winding function. So this right here, this point will be where W of theta is going to be. So as you can see that if theta is getting bigger and bigger and bigger, then that means that it's going to give you another position that's further and further away from the circle going counterclockwise then. So for example, when theta is going to be equal to pi over 2, which is going to be the same thing as 90 degrees, then that means you're going to be at this point over here, because that means that this is going to be 90 degrees. So this will be W of pi over 2. Then if I go all the way over here, then this will be W or function of pi. And then this guy right here will be the W of 3 pi over 2. And once you get to W of 2 pi, which is going to be the same thing as saying 2 pi radians, you're going to go back to the beginning of the circle. So now we're going to take that and we're going to go ahead and implement it into the unit circle then. So here, the unit circle, here's a picture of it. To begin with, a unit circle is basically a circle where the radius is equal to 1. So hence, that's why it's called a unit circle. And each position on the unit circle will determine what is the cosine of that angle value, what is the sine of that angle value, and so on and so on and so on. Okay, so here, let's go ahead and begin. Now, as I said, this chart right here, this is basically just a regular coordinate axis. So that means that some of these coordinates we actually know. Over here on the far right, this coordinate is supposed to be 1, 0, because again, your center is going to be 0, 0, and your circle is of radius of 1. Then on the top, we have the coordinate 0, 1, and then the far left is going to be -1, 0, and then finally on the bottom is going to be 0, -1. Now, in the circle, we're going to go ahead and discover how to find a cosine of a certain angle or sine of a certain angle and so forth and so forth. And the way we're going to do it is by looking at the coordinates, okay? So here, what we'll do is we're going to go ahead and focus on one of those triangles right now. So one of the triangles could be this one right here. So let me go ahead and kind of isolate it. So this over here, we're going to go ahead and draw that triangle, okay? Now here for that triangle, you'll notice that the x-coordinate is going to be the horizontal and then the y-coordinate is going to be the vertical. And I'm going to take that triangle and we're going to go ahead and pull it outside over here. So let me just draw it over here on the side so you can see exactly what's happening. Now for that specific position, this angle is going to be 30 degrees. So then that means that the angle that we're referring to is 30 degrees over here. And in terms of what is it in our radians, that is supposed to be the same thing as pi over 6. By now, you're supposed to be able to interchange between the two, between a degree and also a radian. And keep in mind, a radian is just the same thing as a degree, except it's looking at it from a circumference perspective, meaning that you're going to rotate a certain amount on the unit circle then, okay? So here it is, 30 degrees, 30 degrees, and then pi over 6, okay? Now this over here is going to be my right angle because it's a perpendicular since it's a horizontal and a vertical. And remember the unit circle, now this length is supposed to be 1 because we said that is going to be the, what's that called, the radius. Now, this is a special triangle that we've seen so many times where we know the length of each side and also each angle according to, well, what we learned in the past, okay? This is a 30, 60, 90 triangle. So what that means is over here, let me go ahead and write the 60 using a blue pen just to make it a little bit more different or distinct. The rule was that, or it's not the rule, the theorem that we proved was that the opposite of a 30-degree angle is supposed to be half of the hypotenuse. So what that means is this over here is equal to 1/2, the vertical distance. And then the horizontal distance, that is going to be then √3 over 2 as a proportionality to the hypotenuse. So then that means the horizontal is this, the vertical is this. Then that means that we have the coordinates over here. The horizontal coordinate is supposed to be √3 over 2. And then the vertical component is supposed to be 1/2. Now, if you're wondering, okay, well, what does that have to do with like the sine of the angle or the cosine of the angle? Well, that's where all of this actually comes in nicely because now we can actually see, according to this triangle, the sine of 30 degrees. Well, what is the sine of 30 degrees? Sine is supposed to be the opposite over the hypotenuse. It's supposed to be the opposite over the hypotenuse. So in this picture, then that means numerically, this is going to be 1/2 divided by 1. So what that tells me is that the sine of 30 degree is really just the y value that's over here. So that's the nice part about it. And if we go by the same idea, then that means the cosine of 30 degrees is then going to be the adjacent over the hypotenuse. And that is going to give me √3 over 2 divided by 1. So that's really just the x value that's over here. Okay, and in fact, anywhere on the unit circle, the nice thing is that whatever triangle that you're setting up, it's always a case where the x value, the x coordinate, is always going to be the cosine, whereas the y value is always going to be the sine because, again, your hypotenuse is equal to 1. Okay, so here you can see that this is going to be x and this is going to be y. Well, according to the triangle, the arbitrary triangle that we have, cosine of the angle theta is supposed to be x over 1, so that's equal to x. Whereas the sine of the angle, the central angle, is going to be y over 1, so that's going to be y. Okay, so there it is. All right, now we can go ahead and move into the other triangle that is next to it. So this time, let's go to the one right above it. Okay, so I'm going to go ahead and draw, okay, using blue so you can see what's happening. I want to find out what is the coordinate over here, so then that way I can determine what are the x and y values, because that's going to be another special triangle. So here's the blue part. Okay, I'm going to go ahead and draw that triangle over here. The angle that we're referring to in this case, that's going to be 45 degrees because that's another special triangle that we have. So over here, I'm going to go ahead and say that this is going to be 45 degrees. That's going to be our central angle. And the radian value is supposed to be pi over 4, okay? So now we'll go ahead and fill that part in just a little bit. Let me go ahead and erase all this stuff over here on the side that we created and create that triangle that is supposed to be blue. All right, so let me get rid of this, get rid of this, get rid of this, get rid of this. Okay, there we go. Okay, so here, that blue triangle that I just formed, remember the central angle is supposed to be 45 degrees. So that is going to be over there. The hypotenuse, once again, is supposed to be 1 because we are in the unit circle. And then this is going to be the y coordinate, this is going to be the x coordinate, and this is going to be a right angle. So according to this picture, we actually know the length of x and length of y because, again, this is a special triangle where we know the hypotenuse. The y value is supposed to be equal to √2 over 2. And then the x value is also equal to √2 over 2. And you can verify those according to the Pythagorean theorem if you want. So according to this triangle, then that means that the sine of 45 degrees is going to be equal to x, which is going to be, oh, sorry, not x, it's going to be y over 1. So that's going to be √2 over 2 over 1. Now, in addition, you can also say, if you want, the sine of pi over 4, which is actually the same thing, because remember, 45 degrees is looking at it from an angle, from a central angle perspective, and then pi over 4 is looking at it from a circumference perspective. This right here, this is going to be in degree form. This right here, this is going to be radian form. So they actually solve for the same thing. So next time anybody says, hey, what is a sine of 45 degrees? That's the same thing as saying, what is a sine of pi over 4 then, okay? Radians and degrees, you're supposed to be able to interchange between the two. So the cosine of 45 degrees, or the cosine of pi over 4, then that is going to be then equal to the x value over 1. So that's going to be equal to root 2 over 2. So then if I put those into my triangles, then this guy right here is going to be root 2 over 2. And then this is going to be root 2 over 2 as well. Okay. So now we know what is the sine and cosine of this 45-degree angle. Now we go to the next part. And if we go to the next part, that one, well, we don't actually have a lot of work to do because we technically have that triangle already. Okay. So here, let me first go ahead and draw that triangle over here, okay? So for this triangle, the central angle that we're referring to for the green one that we're going to draw is going to be 60 degrees, okay? So this is going to be 30, 45, and then 60. So here, let me just draw that over here. So this is going to be a 60-degree angle. So here, we'll go ahead and write that 60 degrees, okay? And in terms of what is it in the radian, that is going to be pi over 3. Now, the 30, 60, 90 triangle, the red triangle and the green one that I'm about to create, well, those are just kind of like flipped. So what I'm trying to say is we actually solved for it already. The values over there, according to my 30, 60, 90 triangles, this right here, the x is going to be 1/2. And then the y value is going to be root 3 over 2. Okay, and then we're done. All right, so there it is. That's going to be my first quarter of the unit circle. Okay, so for this unit circle, we know all of those already because we already solved for them in the past, and now we're just kind of organizing them better, so then that way we can go beyond it. Okay, now here's the part that gets interesting. Remember, the original question is, well, what about if we have a triangle that is greater than 90 degrees? How does that actually work for all of this? Well, that's where the other parts of the unit circle comes in. So this time, let me go ahead and go beyond the 90-degree angle and show you what I mean. Okay, let's go ahead and draw a triangle that's over here. Okay, so this triangle, we're gonna go ahead and draw this one. Okay, so you'll notice that what we have right here is another special triangle. But the angle that we're referring to, according to the winding function, is we're going to go from the x-axis going all the way around over here. So that angle is going to be equal to 120 degrees. Okay. Over there, we can probably figure out by symmetry what are some of the coordinates over there. The angle that we're looking at, again, as we said, is going to be 120 degrees. In terms of what that is in radian form, well, that is going to be equal to 2 pi over 3. And then now if you look at my purple triangle that I just created and the green triangle that we created, we actually know the coordinates already, okay? The coordinates, the x-coordinate, well, that is going to be the same length horizontally. So that means that this guy is going to be equal to 1/2 for the x. Whereas for the y value, that's also going to be equal to root 3 over 2, and that's going to be the same height as the green triangle. The only difference now is that there is a negative in front of that x value because we're no longer in quadrant 1, but we're in quadrant 2. Okay, so then according to this triangle, well, those are going to be my coordinate. And now that we have that, then that means that we can now extend upon the 90-degree angle. According to this, we can actually find out what is now the cosine of 120 degrees. Or we can say, what is the cosine of 2 pi over 3? The same thing. Well, according to the unit circle, then that means that I'm going to go to that position and I'm going to go ahead and look at the x value. Because remember, once again, the x value is what's going to give the cosine of that angle then. So then that means that it's supposed to be equal to -1/2 then. Okay. So For these triangles, we can go ahead and fill out the whole thing and then go all the way around. And eventually, once we get all the coordinates, then that means that we know all the trig ratios for each one of them. So here, just to kind of like, to speed up the whole process, I basically drew out the entire unit circle over here. So you can see all the coordinates over there. You can see all of these central angles. And then you can see also their corresponding radian values in each respective quadrant. So this right here is probably something that we're going to have to memorize in order to figure out, bigger things. Okay, so this is going to be what is known as a unit circle. Okay, so here, let's go ahead and test out the unit circle so you can understand how that actually works out then. So let's go ahead and say I want to find the 6 trig functions for 5 pi over 6. I want to find the 6 trig functions for 5 pi over 6. So the question here, let me just kind of translate what that means. If you're wondering, first of all, okay, hopefully you haven't, hopefully you can know this by now. 5 pi over 6, that is the same thing as 150 degrees, because if you remember, 5 divided by 6 multiplied by 180 degrees, because that's what pi is equal to. 5/6 of 180, that's equal to 150 degrees. So this is kind of like saying, what is the sine of 5 pi over 6? Or we can say sine of 150 degrees. Then I also want to know what is the cosine of 5 pi over 6. And what is that equal to, the ratio? What is the tangent of 5 pi over 6? What is that equal to as a ratio? Then there's also cosecant of 5 pi over 6. And then there is the secant of 5 pi over 6. And finally, what is the cotangent of 5 pi over 6? So those are the 6 trig functions that we're referring to. And I want to know what is it going to be according to that angle that we have then. Okay. Well, once again, all we have to do now is just look at the unit circle. So if I want the sine of 150 degrees or the sine of 5 pi over 6, then I'm going to go to the unit circle over here. We're going to go start from the central angle 3 o'clock position, and we're going to rotate all the way to where we see 150 degrees. Once we get to the 150 degrees, we look at the coordinate, and that's going to tell us the sum of the trig ratios right there. The x value, if you remember, right, we said on the unit circle, the x value is always going to be the cosine of the angle, whereas the y value is always going to be the sine of the angle. So according to what I need to solve for, then that means that the sine of 150 degrees, or the sine of 5 pi over 6, is going to be equal to 1/2, because that's the y value that is over there. Then if I want the x value, then that is going to be the cosine. So that, according to what we just have, is supposed to be negative root 3 over 2. Then if we know sine and cosine, then that means that we know cosecant and secant, because those are just their reciprocals respectively. So cosecant is going to be equal to 2, because that's the reciprocal of 1/2. And then secant is going to be equal to negative 2 over root 3. Or if you want, you can write it as negative 2 multiplied by root 3 over 3. Either one of those should be sufficient. And then where's tangent? Tangent, we're supposed to take the sine divided by the cosine. So that is going to be the sine of 5 pi over 6 divided by the cosine of 5 pi over 6. So numerically, that's 1/2 divided by negative root 3 over 2. If I multiply 2 to both top and bottom, then we're going to get 1 over root 3 negative. So that's going to be my tangent of 5 pi over 6. Whereas the cotangent is the reciprocal of the tangent. So that means it's going to be equal to negative root 3 then. Okay. All right, so that right there, eventually you're going to have to be able to memorize this, and hopefully, that is something that we can do within the next few days or so. And as soon as you do that, solving for these type of problems will become easier and easier. Okay. All right, thank you so much for watching. Oh, sorry, wait, actually, there's a little bit more. I just want to go through this part over here. Sorry about that. The last part is, okay, so let's say this time, let's say that if I have sine of theta is equal to negative 1/2, and theta is going to be located in quadrant 3, then what are the following then? What is the cosine of the angle that I have minus pi? and also what is the tangent of the angle that I have plus pi over 2. Okay, so for this one, let's just go ahead and see what that means first, okay? So first of all, I have sine of theta is equal to -1/2. And that means that theta is going to be some value that's on the unit circle. Now, in terms of where that is, the best way you can think of it is that this is the same thing as saying y is equal to -1/2. So then that means that we are located somewhere in quadrant 3, or we are located in quadrant 4 because that's where y is negative. But since we're told that theta is in quadrant 3 specifically, then that means that we're going to draw a triangle that looks kind of like over here. So that is going to be my angle theta then. So it's going to be something like this. Okay, so now that we know, we have a better idea as to where theta is located, we can even be a little bit more specific. That is a value that's on the unit circle because remember, y is supposed to be sine and it's equal to -1/2. So according to the unit circle, let me go ahead and scroll back up over here. We look for where you have y is equal to -1/2, which is located right here. So my angle, my theta, is going to be 210 degrees. Or if you want, we can say 7 pi over 6 because that's the radian form. So then that means going back to my question over here, this guy is going to tell me that theta is going to be equal to 7 pi over 6. And as soon as we have that, then we can now go ahead and throw theta into each one of those equations and solve for it then. So the first one, cosine of 7 pi over 6 minus pi, that is going to be the same thing as cosine of pi over 6. What is cosine of pi over 6? That is equal to, according to the unit circle, √3 over 2. And then for tangent, same thing then. So that's going to say tangent of 7 pi over 6, and then that's going to be plus pi over 2. Now, that is going to give you something kind of nasty, unfortunately. That is the same thing as tangent of, let's go ahead and get a common denominator. That's 7 pi over 6. And then plus, that is the same thing as 3 pi over 6. So the total in this case is going to be equal to the tangent of 10 pi over 6, which I can then reduce to tangent of 5 pi over 3. So once again, we go to the unit circle, look for 5 pi over 3. That's going to be located right here. And if I want the tangent, then that means I need to take the sine divided by the cosine. So we're going to go ahead and pull out the sine value and the cosine value, divide one from the other, and that's our answer. So the sine value, according to what I just saw, is supposed to be -√3 over 2. And then the cosine value is supposed to be 1/2. So take one, divide by the other. So -√3 over 2 times 2 over 1. So 2 cancel out is equal to -√3 then. Okay. All right, so there it is. And for this unit circle, one last thing I want to mention is this is actually very, very easy to memorize because there is a pattern to this unit circle to make things a little bit easier. If you look at the x value and the y value, there are only 3 values that we have to memorize. 1/2, √2 over 2, and √3 over 2. Okay, I'll write it on the side. It's either 1/2, √2 over 2, or √3 over 2. And depending on what quadrant, it's either positive or negative. Now, then if you think about like where the positions are, okay, well, those 3 values, you'll notice that the pattern that I try to memorize it in is the following. The numerator is really where you're looking. The denominator, all of them, they have a 2 in the denominator. So the numerator, if you notice, here's the pattern. It's going to be 1. Oops, sorry. This is going to be a 1 over here. And then the next one is going to be 2. And then afterwards, it's going to be 3. So it's going to be 1, 2, 3. And then 1, 2, 3. So 1, 2, 3, 1, 2, 3, and so on. Okay. So if you can memorize it that way, I think that'll make things a little bit easier. All right. Thank you so much for watching. I will see you guys next time then. Have a good one. Bye.